In this video, we're just going to look at the two types of substitution, the one you learned last year and the newer one. So this first one, again, as I've mentioned before, I would always start by identifying whether or not I could just do the integral some old way. You know, is it just something I could undo power rule or undo a trig function? And what you see here very quickly is it's not, because we have the product of two functions. The next thing that I would look for is substitution. Not to say integration by parts is wrong. It is a great way of dealing with products, but it's more work. Substitution is easier and should be the thing you use if you are given the chance. So in this case, I guess I usually look to pull constants out front just so I don't have to think about them. And then I look for the composition. And you know, this is a review of substitution, so if you're forgetting some things, you might want to go back and watch some videos from last year. But this is kind of my way of doing substitution. I pick u to be x cubed, so du is 3x squared dx. Well, you'll notice, I'm going to just put this in a blue box, I have got x squared dx. So I could replace that with the 1/3 du. Okay, so what can happen here is I'm going to take this red box, and this is going to be u, and these blue boxes I'm going to put up here is going to be 1/3 du. So my integral becomes, I'm going to remember that 4 out front, becomes the sine of u multiplied by 1/3 du. Well, same type of thing. I want that constant out front, so it becomes 4/3. The antiderivative of sine of u is negative cosine of u. So this becomes negative 4/3 cosine of u plus c. And to finish the problem off, I should put it back in terms of x because that's where it began. Now the second example, you'll see that we again have a product, so the old methods are not going to work. If I make ux plus 4, which is usually the obvious choice because it is a composition and this thing is being raised to the 3/2, but you'll notice that du is out here, but there's an additional term. Look for things with the same power. Okay, so if I make ux plus 4, then du is dx. So I'm going to be able to replace this with a u, this with a du, and I can replace the x with a u minus 4. So this becomes the integral of u minus 4 multiplied by u to the 3/2 du, which I would multiply out to be u to the 5/2 minus 4u to the 3/2, and then we integrate. So raise the power and divide. And resubstitute. So, with substitution, look for products that you can use substitution with where you can avoid integration by parts. If these kinds of things didn't work, you know, if here was u and du was not around, then we'd have to use some other method. Or if it was a product where the du wouldn't have somehow saved us from the product. Like here, du got rid of the product. It wasn't x squared anymore, it was just the sine of u. And here, the same thing. We were able to get rid of the product and turn it into something we could just use power rule for. If that's not possible, then we have to go to integration by parts.